So we know that DNA is that ticker tape inside nearly every cell in your body, built from a long string of nucleotides called A, C, G, and T. And it's the order of these nucleotides that helps to determine who you are and tell your ancient family history. How does it work? The answer lies in how your DNA is packaged inside your cells. When we look at a section of DNA with its particular order of A's, C's, G's, and T's, it's a little bit like looking at a page from a book. Each page is lined up alongside a lot of other pages, one after the other in a row. Together, this long string of pages composes a chapter in the story of you. This chapter is something we call a chromosome. A chromosome is a package of DNA that gives you a set of traits that make you, you. Inside your cells, there are exactly 23 pairs of these chromosomes. Hidden on these chromosomes are little clues that can tell us exactly who you're related to, going back thousands of generations, all the way back to the very earliest days of our species. So what are these clues? Let me explain. When you have children, your DNA is copied and passed on to them, and that's why kids tend to look like their parents. All of those billions of A's, C's, G's, and T's, painstakingly duplicated in every generation. Now here's the trick to finding our clues. The copying isn't perfect. Occasionally there are mistakes, like typos. These typos are called mutations, and they're pretty rare, an average of just 100 typos out of the billions of A's, C's, G's, and T's passed on to your kids. Most of the time, these mutations are harmless. In fact, they may serve a very useful purpose. They make each generation just a little different genetically from the one before. Over many generations, these little mutations led to the evolution of all sorts of useful things. Our opposable thumb, our big brains, even our remarkable singing ability. Or not. But most of these mutations have absolutely no effect on us. They're simply ancestral baggage. And here's the most important part of our story. These little genetic typos are passed on in the DNA of every descendant who follows. What that means is that if you and someone else have the same mutations, you share an ancestor, the person in the past who first had that typo in his or her DNA and passed it on to the two of you, a marker of descent. And that's exactly what we call these typos, markers. These markers allow us to create a family tree for everyone alive today. You, me, everyone walking around on planet Earth, we all fall onto a branch of the human family tree. And by examining your markers, we can tell you which branch of that tree you're on.